element will be overflowed. That says that stack is completely full. And next we're gonna see another example, which is underflow. Opposite to overflow is my underflow. Now we're gonna see what is this underflow as well. Now I have taken, yeah, again I'm choosing the stack. See, now what I'll do is I'll completely fill all the elements. I have taken the size to fill the stack completely with like 5 elements. I have capacity to fill 5 elements into the stack. So now I'll insert first element, I'll insert second element, I'll insert third, and I'll insert 4, and I'll insert 5. Okay, I'll insert 5 as well. Okay, this is completely filled stack. Okay, clear? This is completely filled stack, which is first element is at the last. Okay, if you see here, this is like end, this is the base, this is the base of my stack. Now I want to delete an element. How can I delete my element? I can delete from the top, right? I'll delete this element first, okay, and I'll delete this after. Okay, let me explain you. First I'll delete the first element, which is this, right? And the second trip I'll delete the second part, which is this, and third I'll delete this one, like, okay, I have deleted 2 elements. Now I delete the third element, which is top of the stack again. Okay, I'll delete fourth element as well. Okay, after deleting fourth, I also want to delete fifth element. Every element I want to delete from the stack. That is, I have deleted the fifth element I have deleted, fourth I have deleted, third I have deleted also the second element. At the last I have only the first element. I want to delete this first element as well. So what I'll do, again I'll delete the element. Yeah, I have deleted the last element as well. So still now I want to delete some elements. Are there any elements present here? No, right? There are no such elements present in the stack right now. It is completely empty. Even though I have deleted all the elements, I am trying to delete. What happens? It is pointing down, right? First the top is pointing here when I am deleting the first element. After it is pointing here when I am trying to delete the second most element, and like that it has come into the last element points where the element to be deleted. After that, what happens? There are no such elements, right? There are no such elements to be deleted. At that time, the stack is said to be in underflow condition. Okay, this condition is known as underflow, where there are no elements to be deleted, but still you are trying to delete the elements in the stack, and that condition is known as my underflow condition of a stack. Hope you are clear with this overflow and underflow condition and the principle behind the stack, which is FILO or LIFO. So in the next lecture, we're gonna see how to insert the element into the stack in a programmatical way and how to delete element in the stack. So generally we'll follow the logic like, see, suppose my stack, it is my stack, right? I can't delete or insert an element from this base. Generally this is known as my base. As it is bottom, I'll call it as my base, and as it is a top, what I'll call a top. I'll call top of the stack. So I can insert an element using this top only, or delete the element using this top only. Okay, so first step is, what I'll do is I'll make the top value to be my -1. Okay, first thing, you just say how to declare a stack, how do you do that, and all like insertion, deletion and all that. First stack is like a array where it has only a limit, like maximum number of values. Up to that mark only you can insert an element. Okay, you can't even try to insert more number of elements which is not in the limit of array declaration of a stack. Even though you try, it is like overflow condition. Okay, there is some limit, so we'll use arrays to be arrays. We'll use this arrays to represent stack. It's not like restricted one, you can use only arrays, you can also use linked list. Okay, you can represent stacks by using arrays as well as linked list. Okay, linked list and arrays. So when it comes to array, you have to declare the maximum number of size. Like if I say stack, if I say stack of 100, like it is a maximum number of size of this stack is limited to only 100 elements. Okay, if I say integer, it's like integer numbers I can store into this array, right? Which is called as my stack. Okay, integer I can store, or else I can use float values, or I can use character as well. Okay, this is declaration of a stack. You're gonna declare the stack to be your array type of representation in when you are using array representation. If it is linked list, you'll declare using this linked list. So this is basic declaration of a stack. So and then after that we're gonna declare this top as well. So top is like a number, it's not like something array or anything else. It is like integer number where you're gonna point it to the element which you require. Okay, at the first step, at the very most first step, what I'll do is, at the very most first step, I'll declare int of top to be -1. Clear? So I'm declaring int of top is equals to my -1. So when I declare this, what happens? This is my stack again. So generally when it is -1, it is pointing below the stack, right? The indexes are given as 0. Stack of 0, I can store the first element here, right? The second element I can store here, stack of 1, stack of 2, like that. Stack of n-1 I can store here. What I can store? Stack of n-1th element I can store here. So first I initialize the top value to be -1. Okay, if I want to insert element, what I'll do is I'll insert the element in the stack, and I'll increment the top value to +1. So -1 plus 1 becomes my 0. Now the top value is 0, right? Again I'll try to insert one more element. Okay, what I'll do, I'll add +1 again. What the value becomes? 0 plus 1, 1. That is my top value become 1. And like that what happens at the last, I want to insert element at the last most occurrence, which is my top of my stack. I'll insert. Now the size of this the size of the stack is n, but the last index is n-1 value. So for the value will be incremented to n-1. So to avoid the overflow condition, we'll check whether my top value is n-1. If it is n-1, I should stop here and I should not increment the value of top, or that means I should not insert any element into the stack further. Okay, this indicates the stack is full. When my top value is -n-1, my stack is overflow. Like I can't insert another element further. Clear? So when it is -1, like again, every element every element which I have inserted is deleted. Okay, again what I'll do, while deleting, I'll just decrement the top value. It is very simple. So while inserting, you have incremented the top value with +1, right? Have incremented the top value with +1 every step. Now you're going to delete. When you're trying to delete, you just decrement the top value to be -1. And -1 becomes n, and at last what happens? 1 minus 1, it becomes 0. That means the top value is pointing to the first element. This element it is pointing. I want to delete this also. So 0 minus 1 will be -1. That means my top is again pointing down. Okay, underflow. Like this condition is like underflow condition. When it is underflow, when my top value is -1. So these are the conditions of overflow and underflow. Clear? This is for overflow. This is for my overflow, and this is for my underflow. So this is about the basic of stacks. In further videos, we're gonna see applications of stacks, and we're gonna see everything related to the stack. Like what are the advantages of using this stack, and what are the disadvantages, and what are the types of representation. Likewise, I said we can use arrays type of representation, also the linked list representation for implementing this stack data structure. Okay, till then, bye bye. See you in the next video. Thank you.